Welcome back for the next session. Session 12, we'll be continuing with the exercise sums in 8.4. Today we will be doing the seventh sum. The seventh sum we have to prove that sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta is tan theta. Okay. Now in this result, one thing you can notice that sin theta is common for both the terms in the numerator, and for the denominator cos theta is common for both. So that is the clue here. From that we have to proceed. So we are taking that sin theta out from the numerator. It will become 1 minus 2 sin square theta, and in the denominator we will be taking out that cos theta. We'll get 2 cos square theta minus 1. Now in this, we are going to write this sin theta into 1 minus, we will be writing it as sin square theta minus sin square theta. Now I am going to make a small bracket for only one sin square, and so writing this as 1 minus sin square theta in one bracket. And then there is another term minus sin square theta. That is, I have splitted the 2 sin square theta as sin square and sin square with a negative sign. For the denominator, I have got cos theta out. 2 cos square theta can be splitted in this manner as cos square theta, then minus 1. There is one more cos square theta. I can write like this. So this is one act of simplification, that's all. Okay. So here I have enveloped 1 cos square theta minus 1 as one particular bracket, and there is one more cos square theta because here there are 2 and 1 I have taken like this, 1 as it is I have taken. Now we can write this as tan theta because sin theta by cos theta can be simply written as tan theta, and this 1 minus sin square can be written as cos square theta minus sin square theta. Now here for the denominator, already the tan theta has come to the top, so there is nothing more such term with cos theta, and cos square minus 1 is nothing but minus sin square theta. So that is very obvious. Sin square theta plus cos square theta is equal to 1. Therefore, cos square theta minus 1, the sin square goes to the other side of the equation. Therefore, it gets a negative sign. So I am rewriting this as tan theta into cos square theta minus sin square theta. And then for the denominator, I have again cos square theta minus sin square theta like this. So these both will get cancelled. I am getting tan theta as the answer, which is the right hand side. Therefore, we can write LHS is equal to RHS. Hence, proved. So once again, I will explain to you. So this we have taken that sin theta out from the numerator, and we have got 1 minus 2 sin square theta. Similarly, for the denominator, I am taking 1 cos theta out. I get 2 cos square theta minus 1 for the denominator. Now here the 2 sin square theta is going to be written as minus sin square theta minus sin square theta. Similarly, the denominator's 2 cos square theta is going to be written as cos square theta plus cos square theta. Now out of the 2 sin square, so 1 I am taking this, taking it as 1 minus sin square theta, and there is one more minus sin square theta. Whereas in the denominator, the 2 cos square theta is written as 1 cos square theta is written with this minus 1, and it is looped as one bracket. And there is one more cos square theta, that is plus sign. So I am writing here plus cos square theta. Got it? Now what have I got? 1 minus sin square is nothing but cos square, and there is a minus sin square theta. And then cos square theta minus 1 is equal to minus. Here you may have a doubt. Now you can even consider this. Sin square theta plus cos square theta gives you 1. I want this cos square. So cos square if I want means what that becomes 1 minus sin square. But cos square theta minus 1, the 1 has to come here. Therefore cos square theta minus 1, the sin square goes to the other side means that becomes minus sin square. This can be considered. So I have used this here. So minus sin square theta plus cos square theta, rearranging the terms, both the same terms will get cancelled for the both numerator and denominator. And finally we are left with one tan theta that happens to be the RHS. Hence the LHS is equal to right hand side. Therefore the result is proved. We have to conclude like this. Now children, let us move on to the 8th sum. In the same exercise, sin A plus cosecant A the whole square plus cos A plus secant A the whole square gives you 7 plus tan square A plus cot square A. Now here in this sum I have to separately simplify LHS, arrive at some answer, and separately I have to do for RHS also, arrive at some other answer, and let us see both the answers are matching. So if they match, we can prove the result LHS is equal to RHS. Okay. So let us try to simplify the LHS first. This sum has got a lot of calculations. I want your patient listening. Just listen here carefully. Now LHS is equal to sin A plus 1 by sin A. So if I simplify sin A plus 1 by sin A, I get as, and that again has to be squared. So sin into sin gives you sin square A plus 1 if you take the common denominator. This has to be whole square. So if you whole square it using A plus B the whole square, the first term is sin raised to 4A plus 1 plus 2 sin square A divided by sin square A. Understood? So what I did? I took cosecant A as 1 by sin A, and then sin A plus 1 by sin A, sin square A plus 1 divided by sin A. I have taken the whole square of it, and then I have got sin raised to 4A plus 1 plus 2 sin square A divided by sin square A. Similarly, your cos becomes what? Cos A plus 1 by cos A the whole square. Now I am going to simplify as cos square A plus 1 the whole square divided by cos square A. So that again 3 terms you will have using the A plus B the whole square formula. I will get T2 as cos raised to 4A plus 1 plus 2 cos square A divided by cos raised to 2, that is cos square A. That's how the terms get simplified. Now this is T1, this is T2. I have to combine both. So if I combine, the denominator of this is sin square and this is cos square. Obviously the common denominator is cos square A sin square A. Now what am I going to do? I am going to combine all the 6 terms. So here for all the 3 terms you have to multiply by cos square A, and for all these 3 terms you have to multiply by sin square A. Now let us take term by term. First term cos square A into sin raised to 4A. I am writing this as sin raised to 4A cos square A plus into 1, that gives you cos square A, 2 sin square A cos square A. Now please observe the terms once again so that you have a clear picture of how the terms get arranged themselves. Cos square A into sin power 4A, 1 into cos square A I have written, 2 sin square A into cos square A. Understood? Now plus this cos raised to 4A is multiplied with sin square A. So I have got cos raised to 4A into sin square A. Now plus sine square a into 1, that gives you sine square a, and then plus 2 cos square a into sine square a. So now look at the two terms, 6 terms obviously, 3 from here and 3 from there. So we have to combine. How do you combine? First you take the sine square a and then the sine square a. So for better identification I am striking out. So 1 plus, here 2 sine square cos square a, and there is one more 2 sine square cos square a. Combining I am getting 4 sine square a cos square a. Correct? Are you understanding? Now here there is 1 cos square a sine raised to 4. Here sine square a cos raised to 4. If you consider these two terms, there are 2 factors common. What are they? Sine square a and cos square a. So I am taking sine square a cos square a as the common factor, and then I can get 1. From here I will get 1 sine square, 2 powers reduced, and here 2 powers reduced, 1 cos square a, and the common denominator is cos square a sine square a. Now can you combine all these terms? From here 1, 4 sine square a, this is obviously 1. Therefore again we get one more, 1 into this is obviously the same. So here 4, here 1 more. So totally I will get 1 plus LHS is equal to 1 plus 5 sine square a cos square a divided by sine square a cos square a. I want you to highlight this part. Children, now here 7 plus tan square a plus cot square a, that is your RHS. Let us see how to simplify that. I have told you several times the identities 1 plus tan square a and 1 plus cot square a can be modified to be used as tan square a is equal to secant square a minus 1, and cot square a can be used as cosecant square a minus 1. Why am I doing so? I have to get 1 from 7, I should get 1, and then 5 I should get. So this is the direction in which I have to go. So that gives a clue that these two negative numbers can be combined with that 7 to give a 5. So that is how I have to proceed. I have to think and plan. So I have used this identity. Okay, and it is the not in all the sums will be using the same strategies. It differs from sum to sum. So in this sum this works well, it doesn't mean that in the other sum also it will work like that. So I have to plan and then use the correct strategy for the sum. Okay, so I get 7 plus secant square a minus 1 plus cosecant square a minus 1. Negative number minus 1 and minus 1 minus 2. Obviously 7 minus 2 gives you 5. And then secant square a is 1 by cos square a plus 1 by sin square a. Now take the LCM as cos square a sin square a as the common denominator, and then this becomes 5 cos square a sin square a plus sin square a plus cos square a. We all know what is sin square a plus cos square a. It is 1. Therefore, I get 1 plus 5 cos square a sin square a divided by cos square a sin square a as the RHS. Now compare both the terms. They are one and the same. Therefore, I can write this as LHS is equal to RHS. Hence the result. Hence the result, I can prove the result in this manner. Children, we'll move on to the 9th sum in the same exercise. Cosecant A minus sin A into secant A minus cos A, we have to prove that to be equal to 1 divided by tan A plus cot A. Okay. Now, cosecant A can be written as 1 by sin A. You are very familiar with that. Minus sin A. And here secant A can be written as 1 by cos A minus cos A. So this is 1 minus sin square A divided by sin A. And then here it is 1 minus cos square A by cos A. Close the bracket. 1 minus sin square A is what? We have got it to be cos square A, and here it is sin square A. So both the cos and sin have got 2 powers, and in the denominator they have got only 1 power. So I am cancelling this. So 1 power. So I am getting cos A sin A for the LHS. Now cos A sin A for the LHS. Coming to the RHS. Here I am not doing any conjugation. Why? I have to have a form cos A into sin A. So that is possible only if I rewrite the terms in terms of sin and cos. Okay. So RHS, how does it get simplified? 1 divided by sin A by cos A plus cos A by sin A. Now denominator, first we have to simplify that. So 1 divided by cos A sin A is the common denominator, and then here multiplied by sin, you will get sin square A plus cos square A. Obviously sin square A plus cos square A is 1. So we have got 1 divided by cos A sin A, and then sin A cos A goes to the numerator, and you will get sin A cos A by 1. So this is the same as our LHS. Therefore we can write LHS is equal to RHS. Hence the result is proved. Hence the result. You have to write.